Hello students, welcome back. This is Unit 5 Notes, Section 7.5. Feel free to pause the video at this time so you can write all of the warm-up down, but I am going to go slowly through this one because it is so intense. In the previous examples in Section 7.4, you might have struggled on maybe a couple of problems. I'm going to zoom up for a second here. Some problems that overlap, for instance, like number 13. In number 13, you have to be extremely cautious that you look at this like it's two separate triangles. So if you extract the first one, you have a length of 6 and a length of 9. When you go to compare that to see if it's similar to the other triangle, you have to cautiously add 6 and 2 together to get 8 with a base of x. So when you go to set up your proportion, you're setting up as 6 is to 8. Well, there's two ways you can do it. You can stay within the triangle and do 6 is to 9. Then you have to set that equal to 8 is to x. Or you can do part is to whole, so 6 is to 8, as 9 is to x. So really, I'm doing 6 is to 8 as 9 is to x, but there's also other ways. Like I said, you could have done 6 is to 9 as 8 is to x. It doesn't matter either way, because when you find your cross products, you will get 6x equals 72, and you'll divide both sides by 6, and you'll get x equals 12. So when we go, maybe it's better to label this as a total length of 8. So you're going to set 6 equals 8, 6 is to 8 as 9 is to x. So we just have to be cautious, and this warm-up has a lot of that. Let me erase this and leave it for, let's see, 6 is to 9 as 8 is to x. I'll leave this for you in your notes so that you have it. And there we go. So now you'll have it for when you're doing homework. You'll see the notes on the side of you. All right, so let's go over this warm-up. There's a lot going on with it. The first thing I did was I took a look at the number 1, and I said, well, I'm going to do part is to whole as part is to whole. The question is, what's the whole thing on the right-hand side? So 30 and 15 together is 45. And then what is this part to the left-hand side? Well, I know that the whole thing is 84. I know that the bottom portion of it is x, so it's unknown. So let's say it was 5. Well, what would be left over? 84 take away 5 would be 79. But what if it was 10? So 84 minus 10 is 74. I really don't know what x is, but I can just say that whatever it would be, if I take it away from 84, that is what's left over above it. So that's what I did. I left this part right here as 84 minus x, because whatever x may be, I'm going to take that away from 84. So now that I have all the pieces, I'm going to set up my proportion. I did 30 is to 84 minus x. So in this case, I stayed within the smaller triangle. 30 is to 84 minus x. I did the right side is to the left side. And then I need to do the bigger triangle. So I'm going to do I did right side is to left side. As whole right side, 45, is the whole right side, 84. Again, it's not the only way to set this up. I could have done 30 is to 45, but then I would have had to do 84 minus x is to x. as 84 minus x is to 84. So I have to be cautious. I use parentheses. I do my distributive property. I find the cross products, and the work is all there. And when it's all said and done, the algebra gets me down to 28. So x is 28. So 84 minus 28, 84 minus 28 is 56. So really the top part is 56 and the bottom part is 28. Number 2, this one, I did x. So I did this part, x is to x plus 6. So I did the smaller triangle to the larger triangle. Then I had to go back and do the smaller triangle, 4 is to the larger triangle, 11. So x is to 6 as 4 is to 11. Set that up, find your cross products, distribute, solve, and you get 24/7. We want to leave it as 24/7 because if not, it would be an approximate value. It would be about 3.4, 3.5-ish, 3.4. I just did in the calculator, 3.42857. So just leave it as 24/7. All right, this next one, number 3, I'm again doing 5. This time I did 7 is to 5. So I did the side of the smaller triangle to the base of the smaller triangle is the same as the side of the bigger triangle is to the base of the bigger triangle. Okay, so I could have done 7 is to 5 as 7 plus x is to 12, or I could have done 7 is to 7 plus x as 5 is to 12. As long as you talk your way through it and you're doing and you're staying consistent. And the algebra for that one is to the right, distribute, find the cross products, distribute, solve, and you get 49/5. So you get almost about the number 10. It's 9.8. And this last one is just below. I'll put a little divisor in here. There we go. So this last one, you have 6. So this one, I stayed within the same triangle. So 6 is to 7.5 as the whole thing. So 6 is to 7.5 as 9 is to x. And from there, I found my cross products and solved and got 11.25. And what's cool is 11.25, if we take that and we were to take away the 7.5 that I know, I get 3 and 3.75. 3.75 is half of 7.5, just like 3 is half of 6. We'll get into that in our next unit, in our next lesson. But for now, that was a warm-up. So sorry that was so long. I did want to go over it. So what we're going to be doing is proportions in triangles. We're going to use a side splitter theorem, and we're also going to use a triangle angle bisector theorem. The side splitter theorem is when we have lines are parallel and they're intersected. Okay, and so let's take a look. See above how I did part is to whole as part is to whole? We didn't really have to do that. As long as we're talking about the sides of the triangle that are cut by a parallel. In this case, you see a parallel here. So think about this triangle. Let me do this instead. What we know is that this part of the triangle, the side splitter, notice I'm not talking about the bases. You got to ignore these right here. You can't use those. Ignore the bases. But the sides, A is to B as C is to D. It's almost like they make fractions themselves, right? And if you have an E and an F, what I note is that E is to A as F is to C. And here's what's even cooler. So let me put this over here. So we have A is to B as C is to D. You also have E is to A as F is to C. You also have, and I'm going to erase that, but we're not talking about the bases, remember. E is to B as F is to D. You also have E plus A is to B as F plus C is to D, and so on and so forth. There's so much that you can do with this because of this parallelism that's happening here. That's what's really nice about this, because they're parallel. Again, we're not talking about the basis, so you can't, like in number 3, you can't do 7 is to x as 5 is to 12. That's not possible, because it's not the sides you're talking about. You're trying to compare sides to bases, and that can't happen. So be careful, we're talking about the sides here. So this one is to this one as this one is to this one. Or 7 is to x as that side is that side, knowing that the bases are parallel. Okay, so let's do a couple examples here. Notice you don't need to do part is to whole, as part is to whole. We have sides that are split. These are parallel. So we're going to say x plus 1.5 is to x as 5 is to 2.5. This creates something that's a lot easier because we're not adding to the problem by adding side lengths. We're just using the proportional parts, using the side splitter theorem. So we are going to find our cross products. 2.5 times x plus 1.5 equals 5x. Just finding the cross products here. Let's change the color. Let's show some depth. Let's see. We're going to do this is to that. Okay, so we get 2.5x. Let's see, 2.5 times 1.5 is 3.75. 3.75. We're going to take 2.5 away from both sides. So we get 3.75 equals 2.5x. And we're going to divide both by 2.5. We are running out of room. Let's see. Whoops. Divide both by 2.5. X is equal to 1.5. And there we are. If we go back, think about 2.5 is half of 5, and 1.5 is half of 3. 1.5 plus 1.5 is 3. So that worked out really well. And that's the way that should be. All right, let's do another one. This one should be hopefully a little bit easier, a little bit quicker. X over 16 equals 5 over 10. So we're doing x is to 16 as 5 is to 10. Find the cross products. 10x equals 80. divided by 10, x equals 8. So, yeah, x is 8. Oh, look at that, 5, 10, 8, 16. They're half of one another, so that makes sense. This ends up being, what do we get? We got 3. So we end up getting 3, and we end up getting 1.5. And I will do this. That's the pieces we put together. Actually, I'm going to leave these numbers off because they're starting to get a little bit crowded. All right. And here's a couple more. So I gave you a couple more practice problems. I'll do them quickly. 8 over 10 equals 6 over 8, not 6 over x. This one is x plus 4 over 2x equals 9 over 12. This one is x over 13 minus x equals 2 over 3. I set them up quickly. I'll solve them quickly as well. Feel free to pause if you need to. So 8x equals 60. And 60 divided by 8. So x equals 7.5. This one is going to be 12x plus 4 equals 18x. So we'd have to use the distributive property. So we're going to get 12x plus 48 equals 18x. Take away 12, we get 48 equals 6x. 6 times 8 is 48. So divided by 6, we get x equals 8. Running out of room. Okay, so x equals 8. And this last one, we have, we're going to have 2, 13 minus x equals 3x. Distribute, we get 26. Did I do that right? Yeah. 26 minus 2x equals 3x. Add 2x to both sides. We get 5x divided by 5. X equals 5.2. Let's see. 5.2. I'm going to move these. Whoops. X is 5.2. X is 8. And x is 7.5. Those are some homework problems. And all right. Well, it looks like you got a few done for practice. All right, this next part, real world. So check out this sail. It has, looks like parallel sides. Yep. After they cut out of panels, so the edges of the panels on the sail are right and are parallel. Okay, so we have parallel, 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 parallel. So we're going to set this up and solve for x and y. We have 2 feet is to x as 1.7 feet is to 1.7 feet. I think you see how this is going to work out. X is going to have to be 2 because 2 divided by 2 is 1 and 1.7 divided by 7 is 1. But let's do our, do our cross products, we get 1.7x equals 3.4. And I'm going to get x is 2. And this next one, I'm going to set up y. So I'm going to say 2 is to 1, what I do? 2 is to 3. So I'm going to use this top one and the middle one. So 2 is to 3 as 1.7 is to y. So I'm going to get 2y equals, and this is going to be 5.4. Let me see. Sorry, wait. 3 times 1.7. Yeah, 5.1. So again, for this one, I did 2 is to 3 as 1.7 is to y. And so 5.1 divided by 2 is 2.55. So y is 2.55 feet. Y is 2.55 feet. Yep. We really should replace this with feet. Let me fix that. X is 2 feet. All right. We have another example here of side splitter. Still just as applicable. So here we have the sides being split. We're going to reuse 15 and 26 twice. So here's what I'm going to do. I'm going to do 15 is to 26 as 16.5 is to y. I'm also going to do 15 is to 26 as x is to 30. So I'm going to reuse 15 is to 26 twice. 15 is to 26 as x is to 30. And 15 is to 26 as 16.5 is to y. So I'm going to get 26x, and then 15 times 30 is 15 times 30 is 450. Divide both sides by 26. Divide by 26. Well, this gets me a nasty number. Well, not a nasty number, but we have, let's see. Let's write it as a fraction. So we have 450 over 26. We can do both divided by 2. So we would get x equals 225 over 13. Or we can say, I have to move this up a little bit. We can say this, or we can say x approximately equals 17.31, because 307. So let's say 31. Rounding to the nearest hundredth place is fine. And then this one, let's take a look. So 15 is to 26. So 30 is greater than 26. So our answer should be a little bit greater than 15. And 17.31 is a little bit greater than 15. So that matches the order. And looking at this other one, 15 is a little bit lesser than 16 and a half. So 16 and a half is greater than 15. So y is going to have to be greater than 26. So let's see what we get for this one. We're going to get, let's see, 26 times 16.5. All right, so we're going to get 15y equals 429. So we're going to divide both sides by 15. Y is equal to 429 fifteenths. Now, that does not, wait, 429, is it divisible by 3? It sure is. So we're going to say y equals 143. So 429 divided by 3 is 143. 15 divided by 3 is 5. So we're going to say 143 fifths, or y approximately equals, and we're going to get, oh, actually, it equals exactly a decimal, 28.6. And there we are. So again, 28.6 is just a little bit greater than y. All right. This next one is, this is the second part. Let's see, we're almost done. We have 2 more slides left. This is the angle bisector theorem, the triangle angle bisector theorem. So here's what's really cool about this one. If you have a triangle cut by 2 other triangles because of an angle bisector, check this out. Here's your angle bisector. It's congruent angles right there. You really have a unique set of similar and you have a unique set of proportionality happening. You do not have similar triangles. They don't look similar because they aren't similar. It's very clear. We have to be very cautious that we don't say we have similar triangles, okay? But what we do have are proportional pieces based on the division. So we know that 5, which is opposite the angle, is comparable to 8, which is opposite the angle. Just like 6 near the angle is proportional to x, which is near the angle. So here I'm going to set up 5 is to 8 as 6 is to x. So we're going from right to left to right to left. So angle side length opposite the angle to side length opposite the angle, which is equal to the side length near the angle to the side length near the angle. You don't have to set it up that way. You could have stayed within the one triangle. You could have done, for instance, ignore this one. You could have done 5 is to 6 as 8 is to x, and you still would get the cross products that would get you to where you need to be. So here we have 5x equals 48, and we're going to divide both by 5. So 48 divided by 5 is 9.6. And we are done. But again, if you set it up differently, and I will, here, let me just move this around. If you set it up differently, let's say you set it up, oops. If you set it up like this, 5 is to 6 as 8 is to x, that still would be okay as long as you go in the right order. Angle opposite on the right triangle, angle near it in the right triangle equals angle opposite left triangle divided by angle by side that's near the angle in the left triangle. So this one again, we get 5x equals 48. We're not going to set it up like that, but you can. So in this next one, we're going to do, let's see, 3.6 is to y as 5 is to 8. So we have 5y equals 3.6 times 8 is 28.8. So we have y, we're going to divide both by 5, and we get y equals 5.76. And there we are. Again, you want to make sure your order matches. So if you start here, opposite angle, then you have to go to opposite angle. Then you go to near angle and near angle. So just follow that pattern and make sure you're talk your way through it. If you get a wrong answer, it's because you just switched a number and it's in the wrong spot, which means that two numbers are switched or in the wrong spots. All right, this last one. So we have RS. Let's see. We have our figure at the right. So here's angle bisector. So RS is to something as JR is to KJ. Well, JR and KJ are that triangle right there, KJR, the side and the base. So it looks like the it looks like the triangle angle bisector theorem. So it looks like it's supposed to be this one right here. So we have RS is to JR as KS is to KJ. Order of our letters doesn't really matter because it's just a fraction and we're going to put a number there anyway. But KS would have been the side that mattered. So KS and KJ, and then JR and RS. Those are what work. This next one, KJ and JP. So KJ and JP. This looks like side splitter theorem. So it looks like KS. So it's going to have to be SQ. Maybe I didn't use the same. I should have done circle, circle, square, and square. So KJ, JP, KS, SQ. All right, QL, QL, PM, those two. SQ, it's going to have to be JP, right? Because it's the side splitter theorem. And we're on the outer edges of this triangle, so it's going to have to be JP. Wait, did I do that right? QL, PM, SQ, JP. Yep. This next one, we have PT. We have PT, which is here, and unknown. But then we have TQ and KQ. So TQ, hold on, I need to put my other earbud in. I think one's dying. And I think it's up and running. I just don't want us to lose volume. So PT and unknown, and then we have TQ. TQ is here, and we have KQ, which is, where is KQ? Okay, so we have KQ, this is interesting, KQ, this whole thing here, along with TQ. So we have the base and we have the side length. So this is an angle bisector one. So we have this one, PT, and we also have, it's going to have to be KP. So this is going to have to be KP. All right. KLLW. KL is this whole thing. KL. And then LW is this part. So it looks like it's going to have to be KM and MW. So yeah, KM is definitely going to be this one. All right, this next one, we have something and we have KP. So I'm going to mark KP. And then we have LQ. So we have LQ, which is this. And we have KQ, which is this. So it's definitely going to be PM, but I just need to figure out it. So it looks like PM and KP. Oh, wait, it goes backwards. So KQ and LQ, they meet at Q. So KP, and it's going to have to be MP. Again, order doesn't really matter, but I'm going to try to stick with the best order I can. So LQ goes from the bottom, so from the right to the left, so MP really should go from the right to left if possible. Okay, so now we have JK and KS, so JK is here, and KS is here. So it looks like the two sides, so it looks like in side splitter theorems. Oh, yeah, yep, side splitter. So SQ is here, so it's going to have to be JP. So JP is to SQ as JK is to JKKS. Yeah, that order. JKKS, SQ. It's probably supposed to be PJ, but that's okay. JP or PJ. PJ, JK, KS. Yeah, let's just leave that. Okay, and this last one, and then we're done with the notes. KLKM, KL, KM, and then we have MW, so it's going to have to be LW. LW. Okay, so that's it for the notes, and I'll see you for the last set of notes, which is 7-4. So just finish 7-5 homework. All right.